Did you know that something like 44% of businesses already using generative AI have actually run into pretty significant problems with accuracy?
Wow, 44%. That's high.
Yeah, it is. We're talking about flawed outputs, things that mess up decisions, and even cybersecurity issues popping up. It's definitely a bit of a wake-up call.
Definitely.
So today, in the deep dive, we're going to try and cut through some of that noise.
Yeah.
We're aiming for a fast track to getting really well informed about something super critical in AI right now.
Yeah.
How we actually, evaluate these incredibly powerful generative models.
Yeah, that's key.
And especially for you, if you're a self-learner trying to get your head around this stuff, this deep dive should really equip you with the insights you need. Not just how to build AI, but how to properly judge an AI that creates things.
Exactly. Our mission today is really to help you move past the sort of surface level hype. We want you to grasp not just what makes an AI model seem good, but maybe more importantly, why the right evaluation methods are so crucial and, how to spot genuinely effective, reliable generative AI out there.
So it's about the nuances, really.
It really is. It's about separating the truly groundbreaking stuff from, well, just digital noise or fancy demos.
Okay, so think of this as your personalized guide. We're aiming to give you those aha moments, But without drowning you in jargon or information overload, it's about building that mental model for navigating this field.
Sounds good.
Now, that 44% number we kicked off with, it's not just some random stat, right? It really points to a pretty deep challenge facing businesses, developers, everyone really.
Yeah, it really does.
And what's kind of wild is that even with these accuracy problems, our sources are saying nearly 2/3 of companies are still pouring serious money into AI.
It's a fascinating paradox, isn't it?
It really is.
They're investing like crazy because, well, they genuinely believe generative AI is the key to unlocking huge innovation and efficiency gains.
Right, the potential is massive.
Absolutely. From totally changing content creation to speeding up scientific discovery. But this creates this real tension. You've got this almost limitless potential on one side, clashing with these very real, very tangible pitfalls on the other. It's, I don't know, like the Wild West meeting Wall Street, sort of.
That's a good way to put it. So if you're listening and you're maybe learning AI, maybe building your own projects, or perhaps you're just curious about how these creative machines are actually judged, this is where it gets super interesting.
Yeah.
How do we make sure these powerful tools deliver on their promise?
Yep.
How do we stop them from just generating, well, more problems or those weird digital hallucinations we hear about?
Well, first, I think it helps to understand what makes these generative models different. They aren't your standard algorithms that just classify data or predict a number.
Okay.
Think of them more like the creative engines of the AI world. They're explicitly designed to generate completely new data samples from scratch. They don't just analyze existing stuff, they synthesize new stuff. Okay, so they're like the AI artists or writers.
Exactly, like an artist with a blank canvas or a writer facing an empty page. This covers everything from making incredibly realistic images.
Yeah, some are hard to tell from photos.
To writing text that feels human, holding a conversation, or even spotting really complex anomalies in data that a person might just miss entirely.
Yeah.
They're building new realities in a way.
Moving beyond just analysis to actually creating.
Precisely. And that inherent creativity is exactly why evaluating them needs a totally different approach, a different toolkit.
Right, because it's not just checking if the answer is right or wrong, like in a math problem.
Not at all. It's about really getting a handle on the nuances of how these models, quote unquote, think and create, how they learn patterns, and then how they apply those patterns to make something novel. It demands a much more nuanced lens, one that sort of bridges objective measurement with, well, subjective human understanding. Okay, so given all that complexity, how do we even start to measure something that feels so fluid? And sometimes, yeah, really subjective. Our sources are pretty clear on this. There's no single magic bullet metric.
Nope, definitely not.
One size does not fit all here.
That's absolutely right. Evaluating a generative model is often described as being more art than science. It really requires a holistic approach. You have to consider the technical performance, sure, but also, crucially, how well it works in the real world, how it fits into human workflows.
So blending the hard numbers with like the human experience of it.
Exactly. Combining the rigor of scientific measurement with the kind of subtle judgment you need to appreciate creative output.
Okay, let's unpack that. Let's dive into some of those essential metrics and maybe best practices, things that combine that science and that human subtlety. Where should we start? Maybe the numbers first.
For sure. Let's start with the quantitative side. When we talk about measuring quality, especially for text generation, there are a few key metrics. First up, things like perplexity and log likelihood.
Okay, perplexity. What's that telling us?
Think of perplexity as measuring how, well, surprised the AI model is by the next word in a sentence it's reading or generating.
Surprise.
Yeah. A lower perplexity generally means the model is more confident. It's predicting text that fits well with the patterns of natural language it learned during training. It's basically measuring how well a probability model predicts a sample.
So if it has high perplexity, it's kind of guessing wildly, like it doesn't really know what word should come next.
Exactly. That could lead to really nonsensical or jarring output, which you definitely don't want in a chatbot or a content generator.
Right. And log likelihood.
Log likelihood is a bit more direct. It assesses the raw probability that the model assigns to generating a given chunk of text data. Generally, higher log likelihood values suggest the model is a better fit for the data, more fluent.
Okay, so those two give us a kind of foundational sense of how well the model understands language itself.
Pretty much, yeah, they're foundational.
What comes next? How do we compare what the AI writes to what a human would write? That seems important.
That's where metrics like BLEU and Rouge scores come into play. Think of them like having a very meticulous editor.
Okay.
They compare the AI's generated text against one or more perfect human-written examples, which we call reference texts. BLEU, that stands for Bilingual Evaluation Understudy.
Catchy name.
Huh, yeah. It mostly looks at precision. So how much of what the AI generated also appears in the human reference text? It looks for overlapping phrases, basically. Very common in machine translation.
So it checks if the AI is sticking to the script, more or less, not just making stuff up.
Precisely. Then you have Rouge recall-oriented understudy for gisting evaluation, often used for summarization tasks.
Right.
Rouge kind of flips it. It focuses more on recall. How much of the key information from the human reference did the AI actually manage to capture in its output?
I see. So precision versus recall, two sides of the coin.
Exactly. They're both pretty quick automated ways to get a sense if your AI's translation or summary is, hitting the mark.
Now, there was another one mentioned, self-BLEU. This sounds fascinating, especially for us self-learners thinking about building genuinely creative AI.
Yeah.
It seems to look beyond just accuracy.
Yes, self-BLEU is quite cool. It's like a diversity detector.
Diversity.
Yeah, it's not about comparing to a human reference to see if it's correct. It's about evaluating how varied or, well, creative the model's own outputs are. It works by comparing each piece of text the model generates against all the other pieces it generates.
Huh. So let's see about this. If I have an AI that's supposed to brainstorm new marketing slogans or maybe write different story beginnings, self-BLU would tell me if it's actually coming up with fresh ideas each time.
Exactly.
Or if it's just stuck in a rut, spitting out slightly different versions of the same core concept. Like, I don't know, an AI artist that just keeps drawing the same cat, but maybe with slightly different whiskers each time.
That's a perfect analogy. It's designed to catch problems like mode collapse.
Mode collapse.
Yeah, where a model gets stuck and just keeps generating a very limited set of outputs over and over again. If you want genuinely novel, divergent ideas from your AI, self-BLEU is critical to see if it's actually exploring the creative space or just trapped in a loop.
Okay, that's super useful. So we've got ways to measure fluency, comparison to humans, and even diversity in text. What about visuals? When AI is painting pictures or making photos, how does the art and science apply there?
Right, good question. For visual generative models, we lean on metrics like SM, that's Structural Similarity Index, and also PSNR, Peak Signal-to-Noise Ratio.
SM, structural similarity, what does that capture?
SM is clever. Instead of just comparing pixel values directly, it focuses on things like structure, brightness, and contrast in the image. It tries to measure similarity in a way that aligns better with how humans actually perceive visual quality.
Ah, okay. So it's trying to judge if the AI's image looks right to a human eye, not just if the raw pixel data matches up perfectly. That feels much more relevant for, say, evaluating generated art or photos.
Exactly. It often correlates better with our subjective judgments of quality. PSNR, on the other hand, is a more straightforward calculation based on pixel-level differences. It measures the ratio between the maximum possible power of a signal and the power of corrupting noise.
So PSNR is more about raw fidelity.
Yes, both SM and PSNR are really valuable when fidelity is absolutely critical. Think about tasks like image compression or maybe upscaling an image, super resolution, Or definitely medical imaging.
Right, in medical scans, you need to know every detail is preserved accurately for diagnosis.
Precisely. But, and here's the nuance again.
Uh,
These metrics, like SM and PSNR, might not be the best tools if you're evaluating, say, abstract art generated by an AI, or maybe a stylistic transfer where the goal isn't perfect similarity to an original image.
right, because the goal there is creativity or style, not perfect reproduction.
Exactly. That's where human judgment still plays a massive role. But having said that, these automated methods, BLEU, Rouge, SM, PSNR, they are absolutely crucial for evaluating models efficiently, especially at scale.
Yeah, you can't have humans look at millions of outputs.
You really can't. They give you consistent, reproducible results, which you absolutely need when dealing with huge amounts of generated content.
Okay, so connecting this back to the big picture then.
Hmm.
These quantitative metrics are vital. They're part of the toolkit, but they clearly aren't the whole story.
Not but a long shot.
So to get truly accurate, truly meaningful results when you're evaluating generative AI, what are the best practices, the sort of guiding principles we should follow? Especially for those self-learners building or testing their own models, these sound like the really actionable takeaways.
Absolutely. Let's break down some key best practices. First, and this might sound obvious, but it's critical. Choose the right evaluation method for your specific model and task.
Right tool for the right job.
Exactly. What works brilliantly for evaluating a simple chatbot generating chit-chat just won't cut it for an AI creating, say, complex architectural blueprints or generating critical medical reports.
Makes sense.
Each specific application demands its own tailored evaluation strategy. The task really dictates the tools you need, and often it dictates the right blend of quantitative metrics and qualitative human review.
So don't just grab the first metric you read about. Think about the goal of the AI.
Precisely. Second best practice. Tailor your evaluation metrics to your specific use case and industry.
Okay, go deeper than just the task.
Yeah. A general metric like perplexity gives you a broad sense of language fluency, maybe, but it might completely miss the subtle but critical nuances needed for generating legal documents compared to, say, writing creative fiction or poetry.
Uh-huh.
Every field has its own standards, its own jargon, its own expectations for what good looks like. So if you're a self-learner, this really means understanding the context your AI is going to operate in. What does success look like there?
And this next one feels like it really connects back to that art part of the equation we talked about. Because humans are usually the end users, right?
Absolutely. That leads to the third point. You have to account for human perception and preferences.
Yep.
This is crucial.
How do you do that systematically?
Well, automated scores are great for speed and consistency. We know that. But human judgment often remains the gold standard, especially when you're assessing subjective qualities. Things like creativity, originality, aesthetic appeal in images, or even just how natural a conversation feels.
Right.
So a really thorough evaluation approach almost always combines those quantitative scores with some form of robust qualitative assessment. That could be expert reviews, A/B testing with actual users, maybe even larger user studies.
Getting that human feedback loop.
Exactly. It gives you the complete picture. Technical accuracy, creative quality, and practical usefulness.
So it doesn't matter if the numbers look amazing on paper, if when a person uses it, it feels clunky or weird or just off.
You hit the nail on the head. If it doesn't pass that human sniff test for its intended purpose, it's not truly succeeding.
Okay. And there's one more.
Yes, and this one is really important for anyone actually developing or deploying these models. Evaluate regularly throughout the development process, not just as a final check at the end. Ah, so it's not a one-and-done thing.
Definitely not. Think of it as continuous monitoring. You should be evaluating during training, validating rigorously with test data the model hasn't seen before, and doing periodic human checks
Why so often?
to catch potential problems early. Things like bias creeping in or performance degrading or the model developing weird quirks. It's like an ongoing health check for your AI.
Like continuous integration, but for AI quality.
That's a great way to think about it. This iterative process, this continuous feedback loop, is absolutely crucial for ensuring the model stays effective, reliable, and safe over the long term.
Okay, that makes a lot of sense. Now, as we're pushing these AI boundaries, our sources also highlighted something else, that evaluation isn't just about the quality of the output itself. There are other, maybe more practical things to consider.
Yes, definitely. We need to broaden our view beyond just the generated text or image. Practical considerations come into play, especially when you think about real-world deployment.
Like what?
Well, for starters, inference speed or latency.
How fast it responds. Exactly. If you've got a real-time chatbot or a tool generating content live, how quickly can the model actually produce that response? A technically perfect answer that takes 5 minutes to generate is useless in most practical scenarios.
Yeah, users won't wait that long.
No way. And that ties directly into computational efficiency. How much processing power, how much memory does this model actually need just to run?
The resource costs.
Right. That's a huge factor for deployment. Can a small business afford the hardware? Can you run it on a mobile device, or does it need a massive server farm?
That could be a major bottleneck.
It absolutely can be. A model might produce stunning results in the lab, but if it requires a supercomputer to operate, its practical applicability is severely limited.
Okay.
This also connects to scalability. Can the model handle more users, more requests, without grinding to a halt or causing costs to skyrocket? For anyone thinking of deploying an AI project, even you self-learners, understanding these resource needs up front is vital.
So efficiency and scalability are key practical metrics. What else? You mentioned something often overlooked.
Yes, the environmental impact.
The energy consumption.
Exactly. We're starting to ask, are the huge computational resources needed for training these massive models, and even for running the evaluations, being factored into how we assess them?
Is that becoming a standard part of evaluation?
It's getting there. It's a
Yeah.
growing concern. Training some of the biggest generative models can consume staggering amounts of energy comparable to the annual consumption of several households.
Wow.
So as AI becomes more pervasive, understanding, measuring, and optimizing that energy footprint is going to be an increasingly important part of defining what makes an AI system not just good, but also responsible.
So performance versus planetary impact, that's a heavy trade-off.
It is, and it's one we need to be more conscious of.
Okay, so wrapping things up a bit. This deep dive really shows that evaluating generative AI is, well, it's complicated. It's genuinely multifaceted.
Absolutely.
It's clearly about more than just hitting a high score on some metric. It involves understanding the model's purpose, picking the right tools, sticking to best practices like continuous testing and human feedback, and also considering these crucial practical factors like speed, cost, even environmental footprint. It's about ensuring these incredibly powerful tools are built and used wisely.
That sums it up nicely. It's a holistic view.
Which leads us to a final thought, perhaps.
Yeah.
Something for you, the listener, especially if you're learning or building in this space, to maybe mull over.
Okay.
As generative AI keeps evolving at this absolutely breakneck speed, constantly surprising us with new capabilities, how might our very definition of what constitutes good evaluation need to change too?
That's a deep question.
How do our metrics and methods need to adapt and transform just to keep pace with AI's growing abilities, its spread into new areas, and maybe even its deeper societal impact?
That's the million-dollar question, isn't it? How do we measure something that's constantly redefining what's possible?
Yeah, definitely something to think about. We hope this deep dive has helped you feel genuinely well-informed on this really essential and, fast-moving topic.
Hope it was useful.
Stay curious.